Ready. So for the first thing, we are having these addresses. We will create pointers to catch these addresses, and we'll manipulate those addresses by dereferencing that particular pointer. Okay, so I will add at as the data is 32-bit wide, we will create uint32 variable or the pointer star start with p clock control register. Okay, something like this. I will give name equal to the address. What is the address? 40021014. 40021014. Okay, now you know this is the long data and this is the pointer, so we need to explicitly typecast it something like this, as we have done in pointers in star. Okay, now it looks good. So what is this? You can just name it or just simply say address of RCC AHB ENR. Okay, so we are taking the address. After that we have to create the address pointer for address of GPIOA mode register. Okay, so same thing, I will just copy and change some of the names. Yeah, so it should be P GPIO mode reg. Okay, then its address is 480000 48000000. Okay, this is good. Now we want the address of GPIOA output data register. Output data register, and its address is 48000014. 48000014. Yeah, till here we are having our addresses. Okay, and now by dereferencing it we can change and manipulate different things. So now we are having, or we need to just enable GPIOA clock. Okay, for that now we know this is the register to do that, but what information we need to add inside it to make it enable. Okay, so we know that if we know the address, we dereference it, and only this 17 pin, okay, we should set. So for that setting, this is the rule. So whenever you want to set any bit, okay, you have to use OR operator. Okay, so if you do OR, okay, that particular pin will be set. Okay, if you want to clear, you need to give AND operation. Okay, and by using this AND operation you will be clearing that particular bit. So we are interested in setting it, so one should be set over here, and do not touch any of the bit. That's why all of the other bit should be 0, and when we AND it, when we OR it, all bit will be as it is. Okay, and only this bit will be set. So we are basically making a mask value. Okay, so what is mask? Mask is the value where we put our interested bit as 0 or 1 as set or clear accordingly, and remaining bit should be untouched, and we just use it inside AND or operation. So likewise this will be 0, all of this will be 0. So what will be the mask value then? It will be above 4 is 0, 4 in the hex value we will be calculate 0, then this is also 0, then it is also 0. So 0 0 0. Okay, now this is 0 0 1 0. So what is 0 0 1 0? It is 2. Okay, and above 4 bits will be 0 0 0 0. So this will be 0x 0 0 0 2 0 0 0 h. Okay, if whatever the value of this RCC ENR register, we fetch it by dereferencing the pointer, then OR it with this mask value, and again write it to this particular uh, register. Okay, then we will satisfy our criteria that we can enable this particular GPIO A. So we will do same like that. So what we need to do, we need to just dereference it. Okay, so by dereferencing, this is the dereference of that particular memory location, then we OR it with what address? 0x for what is the mask? 0x 0 0 0 2 0 0 0 0. Okay, so this represent that 17th pin is set. Okay, and now we have to store the same thing inside the same dereference register. So if we do something like this, it will as good as reading by dereferencing that pointer, then ORing it with the mask value which consists of 17 pin is only set. So when we do OR, only 17 bit will be set, and then we will writing it in back into the GPIOA clock register, which is RCC NR by setting bit 17. Okay, bit 17 we will be setting. After that we need to set GPIOA port as output mode. Okay, so for this output mode, in this particular mode reg, okay, in this particular mode reg, we need to set this 10th and 11th bit as 0 and 1. Okay, now for setting this pin as 0 and 1, instead of that we can do a thing that we can clear this register, whole register. Okay, and after we clear, we only set this particular bit, 10th bit. Okay, so not the whole register, we sorry, we should not touch the remaining bit. Okay, just make this remaining bit as it is, clear only these two pins. Okay, and then only set this one pin. Okay, so what will happen when we clear? It will become 0 0, and when we set on the next cycle, it will be 0 1 as the output mode. So for that, as we need to clear only these two pins will be 0 0, and the remaining pin will be high, 1 1 1 1 1. All of them will be 1, all of them will be 1. And what will be the mask value for the clear? So 0x, first one is F, this is F F F F. Okay, so F F F F, then this will be F, and then 0 0 1 1 is 3, so F 3, and after that F F. Okay, then this is the mask value. Now going into this, So in this, first we need to clear bit 10th and 11th in this mode rec. So for that we just need to dereference it or read it first, then and as we are clearing the bit with the mask value 0x f f3 ff, correct, 5 times f then 3 ff, 1 2 3 4 5 3 ff semicolon. Okay, and we need to add it in the same register, so copy equal to, this is good. Okay, in the next step what we have to do is, now we need to set 10th pin this is how we'll make it as output. So for setting this particular pin, we'll just create it as 1, remaining are 0 0, all of them will be 0. I will just remove it and explain it again. Okay, now setting this pin as 1, we need to 1 over here and 0, all of this will be 0, this will be 0, this all will be 0, and whole above will be 0. So what will be the value? This is for clear and this is for set. So for set you should be having 0 0 0 0 0x 0 0 0 0, then this is also 0, and this will be 0 1 0 0 means it is 4. Okay, so 4, then it is 0 0 4 0 0. Okay, so 0x 0 0 0 0 0 4 0 0 will be the mask value for setting. So we need to just dereference this particular register, output register, sorry, the same mode register. Yeah, we can do this. Now we are just setting means OR, and we have to change it to 0 0 0 0 0 and it is 4 0 0. Okay, 0 0 0 0 0 0 4 0 0 mode rec or operation, and this is good. Okay, now the next task is to set PA5 means fifth bit in this output data register. Okay, for that we will just dereference this particular register or it with the value that we will calculate. Yeah, this output data register, this should be set as 1. These are already 0 because they are reserved. Then this is 0, this will be 0 0 1 0 which is 2, and these are 0 0. Okay, so which is 0 0 0 0. Okay, 0x 0 0 0 0, then this is 0 0 0 0 2 0. Okay, 2 0, this is what the mask value will be. So 0x 0 0 0 0 0 to 0. Okay, so this would be something like, yeah, 0 0 0. Okay, this is good. And we have to write the same thing inside it. Yeah, now we are good. So this is forever loop. Before it we have taken the addresses. Okay, now we have dereferenced it and set those particular bits inside it, then made it as a output. And then we have written the data which we want to print it. Okay, so now we need to save it and build it. Once it is built correctly, we can connect our controller and we'll check what is, if the LED is blinking or not. Okay, now I will just right click, debug as debug configuration, just create a debug configuration over here. All things should be fine. We just click on debug. Yeah, now we are in debug mode and we can run the code and see here the LED is blinking. I can show you here. There is no green LED as such blinking. Once we run the code, it is blinking over here. You can see the LED is blinking over here. Okay, and if I reset the code, it is turned off, and now if I run it, it is turning on over here. So this is how our code is running. We can check it. So for here, what registers are changing, we can check it through the debugger. So each registers what we have changed, that should be reflected, and for that we have to go in this Windows show view and you have to check the SFRs. So in the left side you can see, so here you can see different registers are given over here. SFR means special function register. So three different SFRs we are using. One is RCC AHB ENR, second is GPIO mode register, and third is GPIO output data register. So we can search the RCC registers first. Yeah, this is the RCC register, and you can check AHBENR over here. Okay, so and the address of that is 400211014. Okay, so now we can step by step go inside this function. Okay, and we can check if this particular uh, local variable or pointer variable is feeding with this particular data or the address or not. So we can step in, and here local variables you can check, and value inside it also you can check. So as of now there is a garbage value, there is no value inside it. If I step in, the RCC register value will be added to it. You can see the address is now 14 and the value is 20. Same we can check in SFR. So value is 0 cross 14 means 20 in decimal, and this is the address gone inside that particular register. So if we again step in, we need to find out this pointer should be filled in with the address of the mode register. So in the variable you can check that this mode register, this is the address and this is the data inside that. Just check the value of that, whereas GPIO is here, and inside that GPIO mode register is here, and you can see the value is in the decimal 2818 something like that, and it is same inside the variable. Now the third one we need to check if it is filling with the same address. Yeah, so it is also having this particular address and the value is over here, in the SFR, instead of mode rec, we are interested in ODR, means output data register, which is here, and you can check that the value is 28185722. So this is also the same, 28185722. Now we know that all the pointers are filled with correct address, and inside that the data is also copying from the SMR is also the right. And then our next target is to fill all the related bits with the correct values. So for enabling clock, we need to go in this RCC AHB ENR register, go and set the 17th bit of that, and we are enabling the clock for this GPIO-A peripheral. So we will just explore RCC register. Inside that AHB ENR is here, and we are interested in this 17th pin. You can see this 17th pin is, as of now, it is 0. Okay, so whenever I will step in over here, this should be 1. So let's see that. Yeah, you can see when I step in, this particular pin has been set to 1. Okay, and the value of INR register, AHB INR ENR register has been changed. Now this step is more or checking the clearing the 10th and 11th bit. So by using this mask value, we can change it. So we are in mode rec. Okay, here we are interested in 10th and 11th bit. This is 10th and 11th bit. Okay, so this is highlighted at 0 0. So if I step in also, it will be looking in the 0 0 only. Okay, now here we are interested to set the 10th bit. So for the 10th bit, this is the 10th and 11th bit, so this is the 10th bit. If I step in, it should be 1. Okay, so it is 1 now. Now we have configured, we have enabled the clock, we have configured that particular port as a output. Now we are interested to glow that particular LED. Okay, and it is being glown by the output data register. So output data register is here. We are interested in 5th bit. Why? Because it has been connected to PA5. So now on our controller, whenever we press this particular PA5 bit, it should turn on the LED. So as of now, PA5 is 0. Okay, I will just step in, and it will set this particular bit. Disconnect. So we can relaunch it again. Yeah, we can press a breakpoint over here. We can set go. Okay, now we are at SFR. We are interested in this 5th bit. Okay, so once we step in, LED should glow. Yeah, so you can see the LED is turned on, and we can see the 1 is represented over here. So we are at the correct thing, and our LED blinking code is running fine now.